Welcome back, everyone. We got Mike on the line again. Thanks for coming back on, Mike. We're doing
Hello,
another
everyone.
little session.
Happy to be here.
So this one is C-printf parser. So C as in the C language, printf is a sort of function that you can use in that language, and it allows you to print something to the console. So it's kind of like console log. It uses these little, actually console log has this stuff in it. I think a lot of people maybe don't know that, but there are these little control characters that begin with a % sign. A lot of languages have this. Rust has it, sort of, but it's a slightly different syntax. Go definitely has a syntax like this with thumped. So yeah, basically the control maps works like this. C is char, S is string, decimal, octal, hexadecimal, floats, pointers, all that stuff. So let's look. It's easier, I think, always just to look at the challenges. So for an empty string, of course, we return back nothing, so that's fine. For any string, we're going to return back well, nothing, because there's nothing in there. But when we have this %d thing, we're asked to pass back an array containing decimal. Then over here, we see there's like, I don't know, there's this little one here trying to trip us up, %d. I guess in that case, then we don't do anything. Decimal, if there are 3, then they kind of like escape each other. So, okay, so that's how the escaping works. If there are multiple, let's go down to A9 here, then we see that we have string and then decimal that are coming out. So yeah, basically we're going to take this string and we're going to try to get different values out from it. Does it make sense to you?
Yeah, this makes sense to me. So it seems we're doing some sort of like escaping mechanism with the escape delimiter being the % sign.
Yes. Yeah. So where would you start in such a thing?
All right, so it's clear so the overall type of the type level function we're trying to build, right, is from string to a tuple of strings. So I'm going to go ahead and just make this little generic parameter. We know that this s, which is the input, is going to be string. For now, I'm just going to say, s equals s. Now, what we want to do is we want to somehow extract or pattern match and find the letter that comes after every instance of a % sign. So the way that you usually want to do this is you want to use a conditional inference.
Would you be offended at all if we used T instead of S?
I would not be offended at all. Let's use T.
Okay. Just because that's what I do on just for consistency on the challenges. I know the actual challenges themselves use S, but I just don't see the point personally. But anyway.
Totally fair. So now we want to sort of have this be a template literal. So I usually call this L because I want to get what's to the left of what we're sort of dealing with. Then I'm going to say this one is I'm just going to call it X. It is like sort of what we're looking for.
Okay.
Then I'm going to say this is R for right. And now what I want to do is we want to find everything after these % signs. So what I'm going to say is we want to really infer some generic string on the left, then a % sign, some generic string here, a letter or a character, and then we want to infer the rest. So I'm going to ask this question, does T extend this? If so, then for now, what I'm just going to do is I'm going to print out what we get as a sort of debugging mechanism, and otherwise I'm going to just say never. So I'm going to take this slowly, and we're going to see what we get at each intermediary step. So now I'm going to say, let's say foo bar d, like this. So if we hover over here, I'm not sure if you can see my hovering on the video.
I can't see your hovering, but we can use /2. Yeah, I have /2 enabled, I think. It's like, yeah. Okay.
Do you see it? Okay, cool. I don't see it on my machine, but that's fine.
Okay, yeah.
So we have foo and then s and then basically the rest, right?
Yeah,
so
the rest, yes.
Yes. So here's what we're going to do. I'm going to create a output variable to store essentially what we are working with. And then I'm going to say, so basically right now, I think one issue is we're not really checking if something is a valid char code. So if I do Q, right, not in the valid set, it's still going to accept that. So we need to have a type that is basically these char codes. I'm going to say type char code equals key of controls map. And that should give us that union of letters just fine. So now I'm going to be able to say, is X a subset of a char code?
Ooh, I see what you're saying. Could I give you a quick shortcut? You can do that
Yes.
here, right?
You can.
You don't want to?
Well, it sometimes for much more complicated types, what I've noticed is that it can actually cause issues in how it works.
Oh, okay.
We can
No, do it
invest
this way then. That's fine. I
Okay,
have an
yeah,
example that does it the other way. So then this is good. We'll
okay,
see some variety.
cool. So we're going to ask this, and then if this is the case, we're going to pass in the right, right? And then we're going to take what we currently have in our output array, and we're going to append X to that. And otherwise, we're still going to do parse. We're still going to call ourselves with the rest, but we're not going to append anything to the O output. And then if we're done, instead of returning never, we're going to return O. So this gets us, so let's see what we have now. So now we have this, if I change this back to an S, we have the set of like letters that are valid. So now we need to merely convert those to their proper form. And that should be pretty easy via just accessing controls map like this.
Don't
Now
mind
let's
me.
do a little bit of reformatting. Yeah, I'm really glad you did this because yeah, that's my preference as well, to have each type parameter on its own line. I believe all the tests pass.
Yeah, they pass.
Here. So yeah, notably, one thing I'd like to talk about is the fact that I am I forget what the technique is called, but I'm doing tail recursion optimization.
Tail call optimization.
Tail call optimization.
So it's like
yes.
tail call recursion has the tail call optimization thing.
Indeed. So this should, oh yeah, and because we're not using the L variable, we can just change that to string. And technically there's one more sort of like syntactical / type level computation optimization we could do.
Okay.
Which isn't even the one you mentioned, which is we're executing this parse print format twice in two different clauses. What we could do is, instead of executing in two different clauses, raise it one level and then put the X extends char code inside.
Okay. I'm getting excited because you said something that I feel like I know how to do. So you're saying to do this. Let's get rid of this and that. And then let's put these on their own line. It's a bit of an art and a science to do this kind of formatting, but so step one is that or something. I don't know. Like that.
Indeed, yes.
Cool.
Yeah,
Does it matter? I don't know. Do you know if it matters in TypeScript?
I think that I don't know for sure, but my hunch says that this would compile faster.
Interesting. Okay.
Merely because it's not executing both paths. If it was, yeah.
I got you. Let me show you a few. So I have a few. Oh, it doesn't fit. What? I hate when okay. Actually, you know, I remember I decided to go with it even though it doesn't fit. So hopefully people can kind of make sense of what this means, because it's just so hard when you break it up into multiple lines. So this is very similar in some ways to what you did. This uses the extends key of control map thing. So it kind of puts that into the initial block here. This manages to get by. What I like about this one, you probably like too, I bet, is it manages to get by without an accumulator.
Oh yeah.
And then we have our tail, so that's fine. So just imagine the tail, even though you can't see it on screen. And then we're returning a literal array. So this is like the base. This is one of the base cases of recursion. If we match the control character situation, but if we don't, meaning we have some other thing in front of the percent sign, then we just want to continue parsing with that.
Oh yeah, so this one I do notice, so this one doesn't do the tail call optimization.
No.
So
Yeah.
so it wouldn't, I think it would not work if we had longer strings. If we had like a string of 1,000 elements, we were doing sort of stress testing. I think this would
yes, good
have
point.
issues.
Yeah, because that, like you said, yeah. So for anyone listening, this tail call optimization thing has been implemented in TypeScript. So that's something that you can really lean on when you're trying to do things that have like arbitrarily long strings. So here's another one. This one takes a very similar, up to this point, is very similar to the very first implementation. And then we have our accumulator. Does it pass head and, did we pass head and tail that same way? No, we just grabbed. Oh, interesting. So what's going on here? What do you think's happening on 92 and 96?
Yeah, interesting. So we are grabbing, so that's fascinating actually. So they're including the first element, which they're calling that head, which is
I probably
interesting,
renamed
first of
these,
all.
in fairness. I tend
Oh,
to
okay.
I try to do that to make them all look the same when we're throughout the whole
see.
course, but like,
Yeah, so I would call this perhaps left, because it's not, I don't think it's necessarily going to be the first, it's not going to be one character, it's going to be like an arbitrary string. But
doesn't
they're
it have to be
passing
one
that.
character?
Say again?
Doesn't it have to be one character?
No, because in fact it would only be one character if that one character has a percent sign next. Rather, it's going to be the entire substring of the string from the beginning to the first percent sign character, in my understanding. But I like to test things like this.
Yeah, like that makes sense now that you say it, but it's not how I thought it worked. But now that you say it, I'm like, actually, maybe it does work that way.
So when I do here, I make a tuple of like head, like all of the variables, so I can like
that's
see what's
cool.
going on.
Oh, that's a good little trick. Tail never or something. Okay.
Yep.
So okay, let me try to get that to fit on the screen. That is very interesting. I love that. Man, Mike, I always learn something cool whenever we do this. That is a great debugging trick. Okay. Type x equals test. And then we have to put ASDF. Okay. So we have some test material in there. Yeah.
Yes. So the interesting thing about the approach you just said is we're putting the head, or the left, into the input again, which won't break it, but it is unnecessary because we are, by definition, we've already handled it, so we don't need to put it back in.
So if we did that, it still passes. If we do this, passes.
Indeed.
Right, and then now we're like pretty much exactly like what you had before. Cool.
Indeed. Yes.
Cool.
Yeah.
Wow, I learned something. All right, and so there's one more. This one is by Team Chong, famous on this channel. I also decided to kind of leave this it's a little long. It goes off the screen, but that's okay. So he left some comments I thought was kind of nice. So T extends. Okay, so this is interesting. We have a checking for initial percent sign. I think I didn't copy them in, but if I recall, I think he actually added some test cases for like what happens if the thing is first, because I don't think we have any test cases where percent %d. So like let's try to make one. Let's put percent %d in the beginning. It works. It works for his implementation.
Let's I very much wonder works if it works for mine.
Yeah. Okay. Let's do that. So where's yours? It's up here.
Indeed.
It does work for yours. Okay. Why does it work for yours? Because it matches string matches nothing.
Indeed, empty. It can be an empty string.
Okay. Well, that's cool. So he's handling. So then maybe it's not that good actually. Maybe he's unnecessarily handling that case. But all the same, we grab the rest, and then if we matched, then we can add to our array and then start recursing. But if we didn't match, then he checks the first two characters. Interesting. Okay, so in this situation, this thing that I've highlighted here, string, has to be one character long, right?
Let's see. I well, that's interesting actually. I don't know off the top of my head what this
Let's
would
test it. We have this
do.
thing right here. So let's do string here. Oops. Whatever. Yeah. It does not have to be just one character long. It can be many characters long.
Okay, so what we're saying is %. Okay. Well, actually, so there's a slight difference here. They're putting the % before, right? While we're putting our % in the middle.
Yeah, I mean, that's what this case here is actually doing. So,
Okay, yeah.
so first two characters, %, and then skip it. Otherwise, so there's three times it's recursing at each branch it recurses in the truth case. So otherwise, to avoid matching strings that end with the %. Did we have a string that ends? Did we have a test that ends with the %? So like, let's do this.
We do on line 40.
Line 40. Ah, okay, yeah. So we've had that all along. Well, this is a very different approach. What I like about this person's solutions, Team Chong, is that, at least to my eyes, because I've looked at now dozens of his solutions, it's clear to me that he doesn't look at anybody's solutions or anything before solving them, because it's frequent that this particular solver will have solutions that vary widely from what everybody else does, which I think is really cool.
Yeah.
But I don't know. What do you think about this one?
Yeah, what I would really like to dive into and understand is, so when we're doing, basically this conditional inference with strings is a form of pattern matching, right? And I'm actually not sure of the behavior of when we have ambiguous pattern matches, right? Where we can assign, like it's there's multiple valid assignments, and it's up to the compiler to choose like where we're splitting the string into the variables. I'm very, very, very curious what the behavior is. Like, does string consume one character, or does it consume 0 characters, or
so look on line 102. So there it consumes one character. I mean, I think the default is that but then it contains, okay, because string here at the end gets more. So if we wanted it to grab 2 characters, it'll return E now. Yeah. So
okay, I see. So this is a way to sort of like, it's almost like in a regular expression, like a look forward operation, or a like a slice operation to sort of get at a certain index.
Yes.
So I do like that aspect of the solution.
Yeah, it's kind of interesting. Cool. Well, we learned a lot of things on this one. This was fun. Any closing thoughts?
No, this is a great problem.
Okay, I'm glad you think so, because the next one is printf, not C-printf. So let's go do that one.